Unit 3, transient response. Transient response. Suppose I am having a circuit like this. Let us assume that there is no charge in the capacitor initially. That is V of t equal to 0 at t equal to 0. When t equal to 0, no charge in the capacitor. No charge in the capacitor. It means voltage is 0. It means the voltage is 0. What will happen? The capacitor will start charging towards, let us assume that V equal to 5 volt, R equal to 10 ohm, C equal to 100 microfarad. The C will charge towards 5 volt. How it will charge? If you plot the voltage Vc of t across the capacitor, it will start charging like this. It will start charging like this, like this, like this, like this. At one point, it becomes 5 volt. Once it becomes 5 volt, applied voltage is 5 volt, capacitor voltage also 5 volt. Both ends of the resistor are at same voltage. That's why no current through resistor. Current ceased to flow. Current will not exist once the voltage reaches 5 volt. This part, it remains 5 volt as long as the switch is closed. When the switch is closed, at t equal to 0, here t equal to 0. At t equal to 0, the switch is closed. And remains closed. As long as the switch is closed, it remains, the capacitor, voltage across the capacitor remains 5 volt. Voltage across the capacitor remains 5 volt. Once it reached 5 volt and remains 5 volt, this part is called steady state response. Steady state response. Response means what? Current or, already we have seen this, current or voltage through the component for applied voltage or applied current. This part is called steady state response. Here, it is increasing from 0 to 5 volt during this period. This part is called transient response. Transient response. In this unit, we are going to study about transient response. Here, when t equal to 0, the switch is closed and the voltage increases. What happens to current? If you plot the current, IC of t, capacitor current or resistor current, both ways you can say IR of t, because both are in series. IR of t. It will be start from 0.5 ampere. Initially it is 0.5, then exponentially decreases and it comes to 0. when it reaches 5 volt. So hereafter it is steady state. This is transient response. During transient response, it decreases from 0.5 ampere to 0 ampere. Decreases from 0.5 ampere to 0 ampere. Initially, the capacitor is short circuited. Initially, the capacitor is short circuited because no charge in the capacitor. That's why as soon as the switch is closed, the capacitor acts like short circuit. That's why only resistor will be there initially at t equal to 0 plus. At t equal to 0 plus, just after closing the switch. 0 plus means what is it? Just after 0 plus. The problem here is at t only we are closing. There are two states that is called a dual state. What is happening? How the switch is closed? The switch is closed at t equal to 0. At t equal to 0, the switch is closed. It means the voltage applied at t equal to 0 is changed from 0 to 5 volt. When it is changed? At t equal to 0. At t equal to 0, two values are there. Dual values. Am I correct or not? Is it possible? Is it possible? It's not at all possible. Either I can be here or at my room. How I can be at two places? It's not possible. Like that, the voltage across the circuit either be 0 or 5 volt. Both cannot exist simultaneously because x-axis is time axis. That is not possible. So actually what is happening, this increases like this. It increases, it may take some few milliseconds or microseconds. To change from 0 to 5 volt, it takes some few milliseconds. Let us assume that a few microseconds, say 10 microseconds. This duration is 10 microseconds. But we are assuming, mathematically, we are assuming that it is happening at t equal to 0. If you apply like this, this response is called step response. Step response. Step response. The signal is like step. That's why it is called step response. Because before t, the voltage is 0. Before closing the switch, the voltage applied in the circuit is 0 volt. At t equal to 0, it is changed from 0 volt to 5 volt. So it is looking like a step. It is looking like a step. That's why it is called step input. Step input. For step input, the response is called step response. So we can call this as when t equal to 0, the switch is closed. What is the response? We may ask like that. Or what is the response of the circuit for a step input of 5 volt? For a step input of 5 volt. That is also correct. We can say that a step input of 5 volt. Step input of 5 volt. So this step signal of 5 volt is applied to this circuit. For that, this is the response. This is the response. There are two responses. One is voltage response. Another one is current response. This is voltage response. This is current response. The response consists of two parts. One is transient part and steady state part. Whenever the inductor and the capacitor is involved, there will be a transient response. There will be a transient response because these two are energy storage elements. capacitor and inductor are called energy storage element. We can store the energy in those elements. Because of that, there will be a transient response.